Hello. Today is January 13, 2026. This is SIG Node weekly meeting. Welcome, everybody. We have a few items on agenda, and first from Ryan, update on work group node lifecycle.
Yep. Hey, would I be able to share my screen?
Yeah, you're
Okay, there we go.
yeah.
All right. Okay. All right, you should be able to see it. So hey everyone. I'm gonna be talking about some updates from the working group no life cycle, specifically as it pertains to the declarative node maintenance KEP. And this has been relevant. This KEP has been relevant for SIG Node for several years now. And so there's been some changes or some decisions been made about this, and I just wanted to share and get some feedback from this group. So there's been, like I said, there's been a lot of discussions about this KEP. It's been one that the community has been very interested in for a while for several reasons. People have wanted to do various things with lifecycling nodes, and this also has implications in graceful node shutdown. Several different things that are mentioned in the KEP and in its scope. So these discussions that we've been having, we're at KubeCon and even in the Word Node Lifecycle Working Group, we're trying to figure out what the future of this KEP is, and specifically the scope of it. And there was a lot of questions raised about at KubeCon about like a node, and so, what is it? What exactly is it? Is it a collection of resources, a collection of devices, is it a place to schedule pods? Is it just an API in Kubernetes? And a lot of those questions really brought us to, to question the scope of this KEP. And so we went through, we'd done, we thought about it a little bit, and suffice to say, like with DRA being introduced, we do need to change the scope of this KEP. And so there's been a bunch of discussion internally, or I should say, in the node lifecycle internal working group about what we want to do with this scope change. And we aligned that we would want to create a new KEP with a new design and scope to continue on many of the use cases that were outlined in the declarative node maintenance KEP. So I just wanted to get the reaction from people here, since there was a bunch of interest in this KEP. If there's any objection to that, starting it with a new KEP. I see a hand. Go ahead, Don.
The CAP is been there for a long time. The original reason actually it is to help those bimetal machines, right? So back then, before AI machine learning workload. So this is why I talked to OpenShift, because they have the most of the on-prem users, use cases, right? So, but it didn't fly, I believe, because they already have their own solution how to manage, or maybe it's not like the top priority for the customer. I even look at some other user on those kind of things. But now I'm most interested is for in the AI machine learning workloads, the group definition, right? So the group for those kind of the multiple host training job, multiple host inference job, how we are going to have like do this, like what's the target desire state, how we are going to do the maintenance. That's kind of what I'm looking for. At least that's what I'm interested in the new use cases, because previous use cases I did try to push forward, but it looks like that the interest, the desire is not strong enough. So now it's because it's getting into the AI world. So now I'm kind of that thing. I want to prioritize more for the AI use cases. Yeah.
Yeah, it makes sense. I think definitely. So that's also undermined. I think like really, I'll just do one quick example. I mean, I think like when we run into these accelerators and we see them fail, and it is complicated to orchestrate a drain and then have to orchestrate with the application owner if they're doing training, like to doing checkpointing of these things. And we want to make sure they're not sitting idle. I mean, there's like lots of complication there that goes into this. So yeah, that's definitely on. It is definitely one of the use cases we would want to capture. Was there another hand? I think I saw something flash by my screen. Yeah.
Yeah, so I'd just like to say that like the original design of the node maintenance, we like tried to make like the clear use cases for that. So that was like the drain. So for example, so we could have like a server side drain or for the graceful shutdown, but we ran into like these soft roadblocks, or like as you said, like there is a lot of nuances, especially in the AI world, and basically the design of the API was not relevant for that. So like we had like a specific target, which was a node. Like we could not agree on the states that we should track, or I mean, like the transitions of different stages, like the different like users or clusters can have different semantics on how they do the node maintenance. And we would be basically hard coding the behavior into our own API, and that would be very hard like to push forward. So like I mean, especially like the extensibility part and like the future evolution of the API, that's what we would like to like do better and in a fresh way with the special node lifecycle management.
So clicking through, right? It's a specialized lifecycle management. The idea is to try and reduce scope and make some material progress. Is that the goal, as I understand it? That's how I read the other comments section there from Ryan. So
Yeah.
I think that's always a good idea when the thing's too hard, right? When we're not making progress, like reduce the scope. So that sounds good, but I haven't read any of the details here yet.
Yeah, that is the objective. I think so we've taken a fresh take on this and changed the scope a bit and trying to hold out several things, a lot of things from declarative node maintenance and focusing on a few cases, specifically like the things we would want to look at, like we want to enable some of the some of the flexibility around the node and lifecycle management, and then the other one, which I think is really specific to this group, is this bug. Just to give you a sense of like how we're thinking about this. This bug's been around for a while. It belongs to graceful node shutdown, and it's blocking graceful node shutdown reaching GA. And I guess the way I'd characterize this bug, since it's a big long text, is like it's kubelet amnesia, essentially, where like the kubelet is going through a graceful node shutdown and it loses track of what it's supposed to be doing, and then it continues on after it restarts as if nothing was happening. And so one of this one particularly would be one of the bugs we want to solve as a part of this this KEP, where the idea is that we should be able to remove this idea that kubelet loses its state, and it should be able to rediscover it and understand that it was supposed to be shutting down. So that's I guess that's like a very high level way of describing one of the things we want to capture here. And I guess I'll say one more thing about, since I'm talking a little bit about design, is that this is very much inspired by a lot of the work from DRA and which came from PVCs. I think a lot of the approach is to actually use a lot of the same techniques and how we're actually going about and communicating life cycle, and that's because what DRA has done is provide a lot of flexibility for people to implement like how they want to attach devices. And that concept is appealing because we actually want to do a very similar thing where we want to have flexibility for how we want to transition between two states. And these states are completely arbitrary, and they can come in any order. And so That's kind of like a high level pitch of how when using a lot of those concepts. So if you read through this, you'll see that it is very similar to a lot of those techniques, and I talk about them in more detail. And there's some diagrams in there.
Okay, cool. Yeah, so more like being able to program a specialized lifecycle management into Kubernetes and let the kubelet and everything kind of understand it rather than dictate a prescriptive one that all nodes must follow. Is that
Right? That's right. Yeah, we want to let the user have some flexibility. We should be able to have. I even use the term driver as well. Like that we should be able to allow the end user to define like these specific states and their transitions. And that like being the flexibility part we're missing, and then providing the structure needed to with some APIs so that we can have observability as to like what the desired state is for a transition, and that observability would allow for us to have a building block to build some more advanced systems around this.
cool?
Yeah, I think we would like this to be these states or transitions to be discoverable and like extensible, but also that we could use them like in the core components or the core controllers. We are still having like back and forth like what kind of role the kubelet should be in this case. But yeah, I like the API approach so far. That's what we agreed upon. But the implementation parts and the driver parts, that's still based on the array, but it might be subject to change.
Yeah, so I think maybe or I guess my last thought is or comment would be that to raise this to get your feedback, since this has been a part of this, the bugs are affecting this group, and or many of the bugs affect this group, and a lot of the expertise is here. We have the CAP that we would like to get your feedback and review on. So if anyone that is really interested in this, please come find us, and find us on the CAP. We'd love to get the feedback, and we're targeting we'd love to have this 136, but at least if not, get reviews in so that we can shape this up so that we can get it into an 136 or 137. Okay, that's all I have.
Okay, thank you. With regards to bureaucracy part of it, like assigning labels, so you want 136 label for now, and then correct feedback during this cycle, right?
Sorry, with the SIG Node label. I need
no milestone. Like you want 136 milestone for this to start collecting feedback.
Oh, okay. Yeah, I don't have it. Okay, yeah, I'll add it. Thanks, Sergey.
Okay. Okay, next item is from Divya and Chris. I made Chris a co-host and I don't see Divya. Maybe it's a wrong time zone for her.
Hi, yeah. So I just wanted to highlight some changes on the writable C group kept. Let me try and find which tab this is on. 1 second here. So I'm just catching up on this, Kep. It looks like Divya's been making some changes over the holidays. So I think the main things are taking into feedback that we've gotten in previous sessions, changing this writable C group config option in the security context from like just a simple Boolean, whether or not they're going to be mounted as enabled or disabled. We turned it into a struct type with its own fields for indicating the access mode, and just allows it to be extensible in the future. There's this open discussion on how we handle CPU set isolation, because this is only actually set at the container level, not the pod level. And so the proposed solution was extending the CPU manager reconciler to verify and reset changes to the container CPU set. I'm just at first glance, catching up on this, Kep, I'm kind of curious, like, is there any reasons why we can't just begin enforcing CPU set at the pod level? Yeah, maybe I'll circle back to that question just a sec. I just want to highlight there was an alternative approach here, which was mentioned before, which was maintaining potentially an allow list of controllers, but I think this is less preferred because these are easily worked around. Like a child C group could just create itself and not respect which controllers are writable. And then I saw also on here, I don't know if the author is or the question author is here, but there's concerns expressed on this guaranteed requirement and why it's necessary. But yeah, I guess I'm curious, going back to my question, is there any reason why we can't just enforce CPU set at the pod level, which would work around needing to extend the CPU reconciler to ensure that any container C groups always adhere to what its original value was? Like if writable C groups change the value? Yes, okay, some hands raised. Francesco?
Hello. So I'm not very familiar with this cap, which I will catch up. But what do you want to do exactly at pod level? Let me just give you some context, just to make sure we are on the same page. So the thing is, we want to have CPU isolation, exclusivity, pinning, they're all synonyms kinda, at container level, and the reconcile loop is making sure that every other container is not accessing those. So I'm not completely clear what could be what should be achieved setting at pod level, CPU set at pod level.
I think it's just because with this writable C groups feature, this would enable a container to be able to modify its CPU set.
But they shouldn't even they modify. They shouldn't be on what their container, like the parent container. Because this we also call this feature a subcontainer, right? So they should bounded by container CPU set. So this is why I confused. I have the same question as the Francisco here. Like this content, right? So the pod maybe have the CPU from the index 0 to 10, and this particular container only have the 0 to 5. Your subcontainer writable C group should be up to only 0 to 5, right? So you shouldn't be on that.
I need to double check that because I thought last time we checked, like the CPU set wasn't actually, it was not set at the pod level. And so a container could change it to any value. I might be wrong though. I need to double check that assumption.
I just want to mention that we have a cap to enable pod level resource and exclusive resources allocation at pod level. So it will be worth to check how those features will interact with each other.
Okay.
That's right, Francis.
And small comment about enforcement. So the CRI API doesn't have a means to query what is currently set to the CPU set of a container. So it either means what kubelet needs to look deeply inside the hierarchy and start again assuming like more and more things how the runtime implements the container. Or we need to extend to a CRI API. Or one small scenario is like, well, CPU manager will constantly bugging the hard runtime, saying like set this value to something. So we will just increase amount of messages over the CRI protocol without actually really need.
Okay.
Totally agree with you, Sasha. Yeah, we need
And regarding the setting on this pod level, so it's similar We can do it, but again, it would be probably better to do over the CRI API.
Yes, I agree.
Sorry, just to make sure I understand, you're suggesting rather than having kubelet like inspect the CPU set inside the C group mount, the kubelet would call the CRI API to reset the value.
So that is currently how it's done. So the kubelet for container, it doesn't set the C group's value by itself. It sends the CRI message, update the resources where the CPU set is part of it. And when the actual runtime, like run C or C run, we're setting it at the corresponding hierarchy. And by the way, run C and C run might have a different like subdirectories hierarchy inside the pod C group.
I see. Okay. Okay, I will bring this feedback back in sync with Divya on next steps. And then in the chat there, Francesco, I thought I saw you post something. Okay, it would be really good to stop coupling kubelet with
Yeah.
single
It was a passing comment about what Sasha mentioned. Yeah. Okay. What I can do is review this work and comment about the super manager side and possibly other. So it's in my radar now. I'll get back. I'll comment and we can move forward offline.
Thank you. Yeah, if you can make mention of the keps that you discussed, so we can evaluate how they interact, that's helpful.
Yes, absolutely. I will share.
Great, thank you.
I guess I'm worried that will this cap be in this infinite discovery phase of other scenarios that customer can break themselves? Do we want to cover all of those scenarios? Like, what is the philosophy behind this cap? Because we always will have something that customer can break. Do we want to account for all of that, or like how much of a piecemeal we want to have it?
I guess that's I would imagine that's kind of up to the reviewers. If the reviewers feel like there's an acceptable amount of risk, at least for it being like an alpha feature, and then if we need to iterate on it in future release cycles, we can do that to cover more cases. I'm not sure like how SIG Node kind of avoids this kind of, I don't know if scope creep is the right term, but yeah, any suggestions are appreciated.
It's a question more of what will be the philosophy of what is acceptable risk and customer can shoot themselves in the feet, or what is like what kind of escalation of privileges that customer can have, and what is acceptable risk that we can take. I think for CPU set, maybe it's I'm on the fence here with CPU set, like how much of it is a customer is not taking more CPU, they just taking different CPUs. It's seems like an acceptable risk, but I don't know if there are other opinions.
It depends on the environment. So like the telco workloads where the alignment or like noisy neighbor on the same core is critical, it might be not not good thing. And the same applies to memset. So like if you have a special memory zones and the customer like tries to utilize something what it was not given to it, it also might be bad for overall node state.
Don, you unmuted yourself. Do you want to reply to that, or I have rebuttal?
Me? Okay.
No, you just unmuted yourself. I wondered if you want to speak.
I agree with Sasa. And another thing is, I think it's just since it's Red Bull C group, it is for sub container. Shouldn't go right to the boundary about the container. That's just as simple as that's what I'm thinking. So I think that's more reasonable. Once we open that can of the worm, allow their sub process, like the children process, to modify, and then all those kind of our rules is start to make sense. We cannot reverse that once we open. So that risk cannot take. Let's just hack it and make this whole things. All we are doing about like the handshake between Kubernetes and also the CRI in the long run. Like even like today, we maybe not completely decouple. But once you decouple, if you allow such things happen, there's no way for you to decouple, because there's no clean API at all.
I don't remember the document itself, but have we tried to evaluate the scenario what, let's say, like runc or crun will create a subdirectory and make it writable. So whatever comes from kubelet will be enforced on one level up, but what container actually pinned is one directory below it. It might solve the issue what like the kubelet will be enforcing still something for container.
I just make sure I understand. You're suggesting like if writable C groups were enabled, we would make a subdirectory that's what's writable. The top level container C group is still read only, and so we get all of the kind of like isolation guarantees. I think the only concern about that, and I don't know how important it is that now we're going to be modifying the like path to the C group. I don't know if we want to like.
So theoretically, the path of the C group, it has the hierarchy. So like the kubelet side, the QoS side, when you have pod side, when you have container side. So anything below the container, it's implementation details of like runc or crun. So theoretically, like nothing should look behind the point. Well, actually, even in case of a kubelet, so like behind the point of pod level C group hierarchy, it's already implementation detail of runc or crun or whatever other runtime it is. So the kubelet just says like, well, this is the parent directory where it should be in as part of a CRI protocol. But what is below it, well, it's implementation details of a runtime. So theoretically, underneath, you can create whatever you want and make it writable. But well, for that, you need input from runc and crun maintainers, like if it's doable or if it makes sense to do it.
Okay.
I think we can check that because like originally crun was creating a sub C group because that was the right way to do it when using systemd C group hierarchy. So what you are describing is definitely possible, Sasha. So maybe we can poke folks and see we can get their input. Like I would suggest Giuseppe and Cure.
Yeah, but the thing is what, like, if we want to have it feature, then probably we need to want it to have it as part of a OCI spec. So like to say what, well, container is allowed to modify these controllers by itself. And when agree with runc implementation to do it like closer what crun is doing. As we described it.
Yeah, spec change makes more sense for that. Yep.
Yeah. Sasha, your comment would apply also for NRI plugins, do you or?
Yeah, NRI plugins run where well, practically for we are on the same level as CRI messages. So whatever container does below it, it will be not visible. So NRI will see whatever kubelet asks for or whatever is, well, during the container creation time it will be. So the top level of a container.
That's actually an interesting idea. In containerd, there is I think in NRI there is work on limiting what NRI can do. And right now it's declarative kind of rules. I know Chris and Sam, you were working on that, so maybe it will help with the scenarios as well.
Yeah, this is something we can look at, and I think it'll be good to call it out as an option in the CAP. We can explore that. Cool. Thank you.
And definitely will get us out of a piecemeal of validating every single property. Thank you very much.
Yeah.
Okay, Francesco, you up? And I made you co-host if you want to share something.
Hello. So no, I'm not sharing. So last week, if I'm not mistaken, there was a call to action to take care of perm alpha or long forgotten feature gates. So I started looking at a couple of those, and this is my initial finding. So basically, first and foremost, this is about touch base. If someone else is already doing this work, in that case, we can sync. Is anyone taking care of custom CPU CFS quota period? In any case, we can reach out offline. So my findings about that is that there are two main topics interesting for this forum. The first thing is that this feature gate predated the CAP process, as far as I understand. So there is no CAP guiding this work or design document. And the second interesting thing is that this seems to be one of the cases on which we added a feature gate as precaution. So people were not sure about the impact, not sure about in this specific case, thanks to GitHub archaeology, the decision to add a feature gate was because there is no systemd support, which was added thanks to Derek, which reported the issue on systemd, but the systemd rollout was about to happen when this feature was was being developed. So it was asked later in the development cycle of this feature to add a feature gate to as a safeguard. So those two things combined makes me lean to the decision that we should totally keep the feature, which is make the CPU quota period tunable, but deprecate the feature gate and say, okay, since this is a double file safe, because you have to enable the feature gate and then you have to change the actual value. So all these factors combined made me lean towards let's deprecate the feature gate and just have a single opt-in for this feature. So I have this document on which all the findings are summarized. We can comment on that or offline and move forward.
It's very interesting findings. We have a few customers on GKE using that, so it is useful feature that can be G8. And if you're saying that it was just a precaution, then I'm totally supportive of deprecating feature gate without cap.
Yeah, I have the links which bake my claims, so everyone is welcome to verify and keep me honest. So yeah, to summarize my proposal, which is again subject to change and review, is okay. We keep the feature, we deprecate we just phase out the feature gate. So it becomes you want to change, you change instead of first enable and then you change.
I'm totally supportive. Thank you
Okay.
for doing archaeology.
No problem. It was fun.
Okay, next one is Ritika. I haven't found you in a list of attendee. Please speak up if you're here. No, doesn't look like that. Okay, so there is a cap to review, and then Brian, also same situation. Okay, Ajay, it's your turn.
Hey everybody. Hope I am audible. I just wanted to give a quick announcement and a call out on the new pre-release, the first pre-release for Node Readiness Controller. Like we have that out at the gate. I just wanted to bring this back to SIG Node and get everyone's visibility into this. And looking forward to more feedback if there are any. I will probably send out an announcement to SIG Node channel and the larger community later this week. Shout out to the community contributors who were part of this milestone, just bringing back for kudos. Thank you.
Outstanding. Yeah, I'm looking forward for feedback from real users. Sounds amazing. Okay, yeah, I skipped the item on enhancement for 136. I wanted to make it in the very end. So yeah, 136 release cycle will start soon. There is a proposal to end the feature freeze at February 11th. So we have less than 1 month left. And there is some holidays in between, in US at least. So if you interested to really to contribute some enhancement, please look at this project board and move your enhancement into proposed for consideration. Also, we will start talking to wranglers to help us navigate all these caps. I really hate to beat records again, but we may because I see like so much energy behind SIG Node contributions today. Okay. Does anybody have any questions on cap release?
I think we need to quickly, maybe next week, we need to have the next release planning and the review and the pull in place.
Absolutely.
So we cannot have idea, but every release we have the proper process, because every release we also find some missing items, right? So that's why let's just next week target to go over that.
It's a great proposal. Yeah, as I said, put your cap in proposed for considerations. It will make it easier for us to review it. And if you review something offline, it will speed up process, but then we may discover something new during the official planning. Okay. Okay, I see caps already moving as we speak. That's great. Thank you, everybody. If there is nothing else, it was great to see all of you. Thank you, and see you next week. Bye.
Thank you. Bye.